Okay guys, so today we'll be doing the simply linked list task and be explaining and going through the task. Okay, so basically you have to read about this on your own. I think here let's just give one material and then they said you can Google it and go on YouTube to check on more resource on it. Okay, so there are several ways to solve single linked list, and basically I wanted to show two ways, but I'm extremely tired, as you can see it's in the midnight already. And so I'll just be going through the basic one. And yeah, so um, a singly linked list, as you can see, I googled this because I won't be able to draw this. It's going to waste my time to draw, as I don't have what's this board called, right? So just like Harry, we can in Harry we can save data consecutively in memory, right? So you can have an array that holds 10, 5, 7 beside each other. But a singly linked list, it's almost like an array, but it's different in the sense that it is not sequentially. It is a chunk of data. They call it a chunk of data in which um, 10 might be saved here, and then another 20 will be saved somewhere, another 30 will be saved somewhere, another 10 will be saved somewhere. So you now link them together. Can you see? So they are linked together. That's what is done here. There's a step in which I'm supposed to explain, but I don't know if I will see something that would explain that in these images. But let me just still go here. All right, so basically these are the data, right? And singly linked lists, they are connected in a forward direction. Okay, so they are connected this way. They are not connected, you can't access them the other way around. They are accessed um, forwardly. All right, they are connected forwardly. Let me just say that you can, I think you can access them backwardly, and that will be, we still have W linked list and we have circular linked list. So but single linked list, they are connected forwardly, right? So there's always a pointer to the first node. This thing is called node, and why this one is called node different from arrays, because aside from their data that they are containing, they contain another space which is a pointer to the other one, which is what makes it connect to the other one. Without this guy will just be alone, so it needs to connect to something else, so we can truncate this thing and make this thing connect to another number, right? So that's what we're saying. So this, they have this thing, and then the two together is called a node, right? So it is called node A, node B, node C, node D. So this other one is still called a node, but it is now a pointer which is used to point to the first node. And once you have the first node and you know that the first node is pointing to the second node, so once you just get the hold out of this, once you grab the person's neck, it's just like human, right? We are connected. Our neck is connected to our body is connected to our waist, our waist is connected to our thigh, like that. So once someone grabs your neck, draw you up, the person drags all your body. So we need the head in order to access all the data in this list, right? So this is a pointer that points to this guy. Okay, so pointer, they contain address of what? The first. So it means this pointer would be holding the address of this guy, right? Of the first, right? So the thing with this, how do we then represent this these guys? They use struct to represent it, as struct can contain two or more data of one particular thing, right? So that's why we use struct to represent it. In this case, the struct will contain an integer and probably a pointer, right? So an integer and a pointer. So we'll then declare an head in our main file which will point to this guy, and then this guy will point to this guy. There's a way to analyze how this guy is being done. And one thing you should know, that struct minimally they have three they would have three data, right? They would have three nodes like this. Okay, so minimally. So and then we can have them consecutively like that. So as many as we want, right? There's still something I want to explain. I don't know how I'm going to use. Okay, I probably use whiteboard, but drawing and all those stuff might take my time. So I wanted to explain how these guys are being connected to each other, right? Because when this guy points to this guy, right, this guy is pointing to this guy. So how do we then set this guy to point to this guy? There's a simple logic. There are two ways in which we could do this. Okay, so the second way is we declare another pointer to point to this guy, right? So that pointer is pointing to this guy, and then we then say that point, since that pointer is pointing to this guy, then we then say let me see, then we then say let me see, I think I wrote something down just to guide us in this task. Okay, good. Yes, then we then say so when this one is pointed to this guy and the second one is pointed to this guy, then we then say this guy, right? This guy is, we can then redirect it to this guy. Okay, we can say, we can dereference this guy and say what, like increase it by 1, right? So we're now saying that p at index link, right, or they get index this guy, right, is equal to this guy. And in that place, since it is, so this place will now become if this place is 20, for if the address of this place is 20, for example, this place will become 20, right? And then it will be pointed to this guy. We can do the same thing for this one and then connect it to this guy, but doing that will be wasting a lot of space, because as we are declaring new pointers, we have to allocate memory for them. Okay, so I know it's might be looking confusing right now, but if probably I'm going to create another class which I will explain how this works with whiteboard, so it will be easier. All right, so basically that's it. So let's just quickly go into our project and see how we're going to solve the task, and probably in the task we'll be able to do one or two things and see. Okay, so let me open the quiz. So this one says, what's a node, right? We all know what a node is. It's going to have what? It's a structure, right, with a pointer to the next node and value information, right? So it has a pointer to the next node and a value information, right? So that's what that one is telling us. And it's a space allocated in memory, as I was telling you, that each one you contain here as well, this one you allocate memory for them, right? So that's basically that. So this one says the cell in an array, these ones are not correct, right? So the next thing, array versus single linked list. We talked about array, right? So I said array can contain as value and structure. Yes, because whatever value you give to structure, array too can hold it, right? So this statement is correct. So memory is aligned for an array. Each element are back to back. Like I was telling you, arrays, they are consecutively beside each other, right? But they are not like that for single linked list. So we can easily remove an element from a single linked list. Because these guys are like this, it is easier to just cut one off, because they are they're just pointing. So we can just repoint this guy to something else. We can repoint it to null. We can, you understand? Unlike arrays, yeah, where it is not that easy. Okay, so we can add elements indefinitely to it. Exactly, we can add link elements to these guys, because like I was saying, this guy is pointing to, so we can just make this guy point to something else easily, unlike arrays as well, which it is not easy. Okay, singly can contain as value as structure. Exactly, because they are always even inside the structure, right? So what's the tail of a single linked list? As you can see, we have, okay, not here, let me go back here. As you can see, this is the single linked list, this is the head, this is the tail. Tail is the end of that list would have the null, because it's pointing to nothing, right? Okay, it's pointing to nothing, so it contains null. So null shows that you've gotten to the end of the link and of the list. So this will help us iterate through. Instead of iterating, there's one English they use for it. If I remember, I'll let you know. I think it is transverse. Yes, I think it's transverse. So it will help you transverse. It's the same thing as called iterate, right? So the last one is called the tail, right? So let's go. So the tail of a list is the node with the pointer to the exact equal to null, right? So in a singly linked list, what are possible directions to transfer? I said it is only forward to transverse it, right? Like this is the English I was looking for before, and then it's called forward, right? So forward direction. Okay. So what is the head of the single link? Is the first one, right? It is the first node. So simple. So we are done. So for this task now, there are several ways to do this task. Okay, so whichever way, try it out. I wanted to try so many ways out, but I know that some I might be getting some little errors which I'll be needing to I'll need to to correct, and it's going to make the video extremely long. So instead of that, I'll just try something that I know that would work, right? Okay, so that's what we're gonna do. And then basically I'm going to create my directory. I think last week, no, 2 days ago, I was working on my directory, so I created a command and it kind of deleted the configuration, and then I had to destroy my sandbox, so I just recloned this guy. Okay, that's frozen, so let me just reload it. So while this one is loading, I don't know what's wrong with the network. While it is loading, so it says that we should write a function that prints all the elements of a list. Okay, so if we have all this list, for example, where's that guy? Yes, so if we have all this list, we want to print out all the elements of this list. Okay, so that's what we want to do. So we'll just stop when we get this null. We'll start from the head, we'll stop from when we get to null. So it should be that easy, I guess. This thing always disappoints me all the time. I think it's the laptop, it's not the network, it's the laptop. The other laptop I have, I can't record because the audio is not working properly. I have to go and probably format the system. Let me just disconnect and reconnect. Okay guys, welcome back. My data finished, so I had to quickly recharge. So like I was saying, my stuff cleared off. As you can see, it's almost empty. So cd into index level. it is freezing. I'm tired of this system. So that disconnected again. What do you mean no Wi-Fi found? This thing is wasting my time. Off the Wi-Fi. What's going on with this thing? Okay guys, this thing is really frustrating me. So let me go into, I hope it doesn't fail again because I'm tired of this. Alright, so okay, so make our directory, simply replace this, we'll make our readme. So I'll VI my, if you look at it, we have our main.h is called list.h, our header file is called list.h, so we'll create a list.h. Right, so that's what we're gonna do. We create a list.h and then we'll say if not defined, list.h define. Right, and then we'll say end if. Good. So we want to include some stuff. I think throughout we'll be using standard IO, standard IO.h. So we'll be using our printf function. Also throughout we'll be using standard library, because for malloc, in case we are allocating memory. Okay, also we would include our string.h, because at a point alright, so that is that. So let me still exit this for now. Alright, so what we're going to do, I hope this thing doesn't fuck up again. So should we copy this now? Okay, let's copy it. Remember what we want to do. So we can copy it now. Okay, let me copy it into list.h. Alright, good. So remember what we want to do. We want to print the elements of a list, right? So basically we are going to create the list format, a struct that holds the list. And if you look at this guy very well, you see that the list contains a string and a string length, right? So as you can see, the string here is containing hello, and hello is 5, right? So it contains the string and the string length, and also it will contain, it means that this singly linked list that we are talking about, that we're doing here, is not just one data that is containing. So it's containing a string, words, right, character, and then it's containing the length of the character, and also is containing this pointer to the next, right? So we would add the struct to I think throughout we'll be using that same struct. So we'll add it to our list.h. okay, and then remember that whenever you declare a struct, you have to what's it called, define it, right? Is it definition they call it? Is it declaration? I remember the English word. Anyway, so we will just do struct, right? So we'll call the struct list underscore s. Okay, so as usual, so it contains a string character str. You see it there, that is, it is called str in the main, and then we have a size underscore t, which is unsigned integer, right? So unsigned integer, which is the length of the string, it contains this, and then it will contain the pointer to this. It is called self-referential pointer. That's it. That is what that pointer is called, right? So it will be struct list, the name, right, and then a pointer. So I can call it is the pointer to the next node, right? So I can also use alias, type def, right, I think they use type def, and then they call it list underscore t throughout. All right, so I can do this, and then we'll do what? We'll define this guy, be declare, or I'm looking for the English word. I'm trying to remember the English word. So we'll say struct list s, right, and then it is what is single linked list. Okay, so that's a single linked list, and then we have at str, which is the string, right? String, and it has been malloced, right? And then we have the next one, which is our len, which is the length, length of the string, right? And then we have what again? I think that will be all. Next, which is the pointer to the next node, right? And then we can add description, and we can leave it. Okay, so I think we are done like this. So let's escape this and that. So clear. So the next thing is, let's vi our 0 main.c to test, right? And let's copy it. So copy this guy, sorry, I'll copy this guy and then paste it here, and then escape. Good. So far we have this. So I can create my git ignore, as you know that I love using it, and then I will say I don't want to push in my everything that ends with main.c, and I'm sure those executable will be called something like this, probably, I'm not sure. Alright, so that will be all for now. So the next one will now be our function, right? See, I guessed right, A. So what is the prototype? So we need this guy. So we want to print out the content, right? So we said that it should return the number of nodes that is there, right? It will return the number of nodes. Format C example, okay? And then if string is null, it should print 0 and nil, right? 0 means that this string is nothing, that there's no string, right? So it means if string is 1, if the length is 1, it will just print probably if the string contain nil, normally it will have n. So we can use printf, so that's why we include our standard IO, right? So let's recopy this guy and then we go the file name. So the file name is 0 print list.c. So let me just press it. 0 print underscore list, right? Let's see, because I don't like not okay. I think we're right. I like copying the names because I don't want any name error, because sometimes you'll be getting checker error and you won't know it's just the spelling of what you typed that make you get the error. So the first thing I'll do is I will include my list.h, right? So I will include that, and then I would want to declare, okay, the English is declare. Wait, is it unsigned? Okay, yeah. Size T is the type def name. So this one is just struct size S, right? This is the alias, right? Okay, so print list. Okay, that's what we want to do. Print underscore list, right? So print list is to print the print all elements in a singly linked list. I hope it's not more than 80 something. Alright, so the next one is a let's see, list T, right? We have our H. This one, the H stands for the head. They've given us the head of the string, the list. Okay, this head over here has been given to us. Since they've given us the head, we can iterate through and then get the reference pointers and get the answer. So it's as simple as that. Okay, so it's going to return the number, right? Number of or total number. Going to return the total number of elements, right? Or of nodes in the nodes in the list. Right, and then we'll end it there. Good. So what we do now is first we would declare an integer I, right? So we now say that if our head is pointing to null directly, it's not pointing to anything. It's pointing, now this one is not pointing to null, even if it is 1, right? It is pointing to the first guy, and that first guy is a data, not null. But if this guy is pointing to null directly, it means there is no single linked list. So if our header, right, age is equal to null, then you should just return probably 0, or you should return null, anyone. Just try null, let me know if it works. So that's what we are doing first. So secondly, we can use a while loop, we can use a for loop. Okay, and we'll say I equals to what? I equals to, should we use 1 or 0? I equals to, let's use 1 for example. I equals to 1. So we'll say that as long as h, and then we'll dereference the pointer, right? As you can see, it's a pointer to it. So what we are doing here is, this is this guy. H link, H is the link that I pressed. Okay, I haven't pressed anything. H next, it is next in that structure, right? So the H next, that is, this is the H, is going to have two data. There's going to be H string, there's going to be, like, this is H, see this one as H, so H is pointing to string, H is pointing to the string length, H is pointing to the next is this guy over here. So we are saying H at next, right? That's what we are saying. Okay, so I equals to 1, H, as long as that H at next, okay, as long as this guy is not null, that's what we want to say. H as next, that's the last thing, the pointer at the last, we are dereferencing it to the last place. Okay, so as long as that place is not equal to null, okay, because we are dereferencing, that's why we have to use this kind of null, right? Or we can just use null. I think both work. Alright, then I plus, keep incrementing I. There are two ways to do this thing. So the other way is when I use 0 here, right? Or since I'm not using 0, then let me just keep it that simple. But I think that I prefer that other way, but that other way works best when we have just one stuff. So what we then do is we then say, okay, so this guy would keep going until he gets to that guy. But remember that we want to print out the content in it as well. So we then say, if we have to check, because this one is not even helping us, because this one contains one data. The one we are talking about contains two data now, right? Okay, I think my data has finished again. I have to quickly get another one, or let me just quickly buy data. So I'll seed into my ALX low level. Let me do ls, and then I'll seed into what is it, ox12, right? ox12, right? So I'm working on, oh, I haven't saved it before, so I'll just do vim /0 print lists .c continue. Okay, so let me then save it now. I've saved it, so I'll remove the .0, then I'll vi it back. Sorry, no need of the recover. Good. So we are back there. So so we'll say if, right? Where are we? So we'll say if our age now, right? And then we'll dereference it as well. Sorry. our h at string. So now our h, this our header is pointing to the string first. You know, we have string, we have data, and then we have the link, right, which is the pointer rather. So if our this guy at string is equal to null, remember that this for loop is iterating through. It will come here, it will come here. So when it comes here first, it will enter and check if the string is null, right? So if the string is null, it will print. Don't forget to put this here. Okay, it will print in quotes. Shut up. It will print. We have this format, right? So we have the format like this, and then this one is unsigned integer, as you can remember, and then space, and then a string, right? %s. So you're going to print this thing and then followed by a new line, right? So what will be here? So the value of the unsigned integer will now be h dash this guy, and this one is the unsigned integer is the length, len, right? Is the length, and then comma. But this guy, because it is null, we were told that string should be null. If you go up, it says that look at the format, and then string should be this. So we just copy this guy, right, and paste it there. So because it's string, I'll put it in a quote as well. Okay, so that's that. So else it is not null, right? So we just say else I didn't put curly braces there. Okay, we should print. So if it is not, to just come here and print the real values, right? So print f, we'll have this, we'll have this, we have our %u, we have our space, we have our %s, we have \n, we have comma, and then we'll say h, right, then comma h arrow string str, right, and that will be all. So that's what we're gonna do. Then we'll come down, then we'll now say after it has checked that, you know that it will come back outside to see, and then this guy will increment to 2, right? Okay, this guy we want to return it, that's why we are even using it here, but we need it as well. This guy will increment to 2, right? And then h next is still the same thing. It's still going to be checking this particular one, so we need a way to increment this guy, right? So unlike before where we do a square bracket and put index I here and then to help us, no, we can't do that here. So what we'll do here is that we'll increment it inside this place. Okay, then we'll now say that our h now, okay, is equal to h next, and then I'll explain that to you. Did I just put dot here? Okay, h next, right? So what we are doing here is that we say that this is our h, right? It's pointing here. So at the second time, we say that our h now is now h next, which is this place. So it is now pointing to the next, which is this place, right? To check if this guy is null. So it will continue until it gets here, and then when it points here, it see that it is null, and then it will stop. So by the time it stops, it won't print the last guy, because it has detected that it is null. Okay, so that's why we use this one here. So we then say that it should have reprint that this line, right? So printf this, and then we'll say %u, %s, new line, comma, h dash this, where is it, and then length, comma, and then new. I hope I get the new well. Okay, and then at the end it should return I. Okay, so you can use 0, but when you get here you would have to increase I by 1. Okay, and that should solve the problem. So far I think we are done, even though we had so many glitches from the network. All right, so let's just continue, because oh sorry, let me betty the file, betty 0 prints and list. Let's betty this one. So our list has issue. No execution for parameter length. Oh, I didn't do for length. Okay, in list. Okay, and then in this one we have 17. Trailing statement should be on the next line. Trailing semicolon, no statement. Let's just say 17. Okay, number 17. Let me see. If we now have now. Let's just put this guy here. Yes, now I have my length. Why is this is it capital letter that I used here? Small letter. Oh, sorry, it's supposed to be at, right? No, it's correct. It's supposed to be like this. So why is it giving me issue? So, and then we'll do betty. Let me go use the output here. So print list is correct. No description for parameter len. Yes. At len, that's what I should do. Just remember, I was looking at. I noticed that it looks weird, but don't do it. All right, so let's repeat it. Okay, good. The problem is people that watch would see errors on time than people that are coding. All right, so what we want to do now? We want to compile it, page down. All right. Let's see, we'll get 5 hello, 2 hello, 2 elements, new div, 2 elements. Let's see. Or we'll get errors. Really, a lot of error. So let's check. So include list.h. Oh, maybe it is list.h, not list.h. So ls, it is just ordinary list.h. So I'll vi my 0 print. Good job. Yeah, it's correct now. After that, what I did is this little guy over here was at the top before, so I had to bring it down, and the code compiled. So let me vi into the code back. Vi 0 print. I had to delete it and code it. So we still have our ivh this blah 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 blah. But let me betty it 0 print, because I had to recode it and check, do so many error check. Okay, so I think we are good. So let me compile it. Let me compile. Right, so I think this worked. So let me see, what are we pushing? So I can add everything, and I will say print the content of a singly list, or print the node of a single list, and then I'll hit push. Right, so that is the error we got, that wasted our time. Okay, it's okay, no problem, no problemo. Thank you for wasting our time. Good. Okay, good. So we head on to the next one. Okay, on to the next one. So this one says that we had to write a function that returns the number of elements in a linked list. It's almost like the one we did. You remember? That one was returning the number of elements already. So we just return the number of elements in the linked list. So that's what we want to do. So the first thing I want to do is, sorry about this, my distraction today. I had so many distractions. We are going to scale up now. Okay, good. So the first thing I want to do is we'll create a file, or let me just create this guy, one.main.c. So push down. Okay, copy. So vi main.c. Alright, okay, good. So the next thing is put my prototype, and then, as you know, the h is the head. Vi lists.h, and I'll put this guy here. Why is this guy disappeared? Didn't I copy it? Let me see, maybe I didn't copy it. Okay, I didn't copy it. Alright, so create our file, we'll put this guy there, one list length.c. so bi one list underscore length.c. so I'll insert my guy inside. Okay, I did this so that you can access this guy very well. Before that, I will include my lists.h, and then this one will be list length, which is the length of the lists. Length length of the lists. And then the next one will be at h, which will be the pointer to the head or to the first node, right? And then we have our return, which is the number of nodes, right, in the list. So this one should be quite simple. We'll have it like we did before. It's I. Okay, and I will say if our header is equal to null, so I want to be fast. If our header is equal to null, then it should just return 0, right? Okay, and then we'll say we can use a for loop to do the same thing that we did there. And we'll say for I equals 1, right? As long as h the next, that's this guy. Let me close this guy. Okay, so this guy displays, as long as this guy displays, right, h the next, as long as it's not equal to null, so this one will make it go through transverse through the string, so I say string through the list, and then I plus plus, right? So we then say h, then we will increment the value of h, right, by doing this next, right? And then it's just like that one, we are just truncating the printing, right? And then you should just return I. So it's just like that one. If you understand that one, you'll be able to get it. So this one is B, so let's compile and see. I hope this one doesn't give us error. Anyway, I will have to Betsy one list. Okay, very good. Let me paste this guy. Okay, and then dash 2 element. Let's see. Okay, I think we're good. So let me git add it. Git add git commit return number of nodes in the lists and push it. Okay, so let's check our code. Good. So for this guy now, we write a function that will add a node at the beginning of the list. So what we are doing is, these are the nodes, right? These are the nodes. We want to create one node and add it to this guy. Okay, that's what we want to do. We want to add a node to this list. All right, so to do that, we will need some data. We will need what? The head, but this one is the pointer to the head, and also the data that we want to add. So it's a constant character, a string, right? So that's what we want to do. So for us to add it, first we'll look for the this data. Now we want to know the length. We look for the length of this data, and then they said the string needs to be duplicated. Okay, so in order to duplicate it, that we can use string dub to duplicate. So that's why we include our string.h. So in order to duplicate it, we'll first look for the length, and then I will show you how to duplicate it. And then the address of the new element on null, return the address of the new element, because the new element would be the first now. So that is why the address of the new one. So let's say this one is not there before, we want to add this guy there. This is the one there before, so this p is here before, right? So by the time we add this new one, it's going to return the address of the new one. So that's what that place is saying. So in order not to waste our time, let me create this guy to main.c. Okay, copy vi to main.c, paste it there, exit it, and then what we'll do next is page up and page down, and then we would copy to add node.c. Okay, so vi this guy, and then let me get my prototype. I haven't put this guy in the main.h, right? So let me paste it, go to the main.h. What did I just do? It is list.h. What's this thing called? Is it list.c? I think it is correct. Alright. So what we're gonna do is we'll go back to our file, right? So end. Okay. So we include our lists.h, and then before that we can come here and create our string length. Okay, and let me call it string length, right? Or our length. Remember, we have len to create as well, right? So create our len. Okay, so our len will be length of this guy, constant char pointer to string, right? To get len, we should know that by now. We can use our while loop, we can use our for loop. So we'll just say int I undeclared. So if our string is equal to null, that is, it should just return 0, right? But if not, we can use our while loop or our for loop, right? and then we'll say for. I like using while, so I'll just say I equals to 0 while our string at index I is not equal to null. It's not equal to null. And this is why, because I don't like this place empty. That's why I like using while for this guy. I plus plus, and then it should return I, and then this one will help us calculate this stuff, right? So this guy would put it at the top so that you can see the prototype and know how to use it in our main function that we'll be creating here, right? So that's what we're gonna do, and in this place I will put my comma and semicolon, and then this one I want to document it, and then I'll say len get the length len of str, which is a string, right? And then what is the next thing? We collect a parameter str, which is str, which is the string to get its length, right? And then it's going to return an integer, return the length of the string, right? So good. So this one, let's declare it to. So this one is add node, right? Add underscore node. We didn't even check the question. I think it's, yeah, it is to add a node to the beginning. Beginning of the list, right? And then we have a head, which is the pointer to the head of the list. So we have at str, which is the string to be inserted to the first position, right? And then what else do we have? We have our return value, right? To return pointer to the first node, which is the newly assigned one, right? Good. Good. So what we do is we say to do that, we want to first create the node. We'll first create that node, for example. So to create the node, we'll say struct node, which is list underscore t, right? Struct node, and then we'll give it a name. Let's call it new node, right? Let's call it new node. Okay, good. So we'll then say so we've created a pointer to this new node, right? So we'll say if our head is equal to null, that is you should just return null. Okay, so the new node now will will allocate memory for it. Say malloc, and then size size of, and then list, that's the struct underscore t, size of the struct. So this one has enough memory to save all those data, right? So now we'll then say if our new code is equal to null as well, then it should return null. Okay, so now this where the magic comes. We say if our head, we are dereferencing kind of now, is equal to null, we dereference the head here. Okay, so yeah, this is a pointer. Let me use this guy. So when we have star star head, right, it is getting to pointing to this guy. So basically what we did before was pointer to the head, right? So we're accessing what was inside. So what if the value inside here actually is null before, right? That's when we said it should return up, but now we are now checking what it is pointing to. Okay, so if that guy that it is pointing to is null, it means that our new node next, we are dereferencing our new node and we are checking the pointer of our new node. Okay, so if the head already is pointing to null here, and let's say this is the head, right? This is the beginning, this one is what we just wanted to have. So imagine this guy is not here, it is here. So if this guy is pointing to nothing, it means this guy too will be nothing, right? So we'll just assign null to this guy. That's what we did there. So else, what should be done? Then our new node, right? Else our new node at str will be what? Will be our string. Will be equals to our string. But to get our string, we'll duplicate whatever is there using the duplicate str dot string duplicate function, and we'll pass in our str. For the other one, which is the length, right? Length will now be equal to what? We'll pass in the length function. And then we have one more, which is the pointer. So we'll now say that as at that point, it means that there's something inside this guy. This guy has something now, right? So what we do then is that we then say our head equals to new node. Okay, so now what we did is then this is the new node, then we pass in the address of new node to it. Okay, I think before we start, let me see if we have done that. Okay, I think before we start, if we pass in the address of new node to it, remember that this guy will now be empty, which will not work. So I think before we start, we need to first say new node next, which is that pointer. be equal to head. I think like this, yes. So what we did here is we check if the head is null, right? If, let's say this is the head, so imagine this guy is not here, right? So head is pointing to this guy. So if it is null, then it means that there's no need of um, doing this. We just say um, if our head is null, then the link of this one. So if this one is already null, right? Okay, let's say our head is here, is pointing to null, right? So what we just do is we just link this guy to head, right? That's what we just did. We just passed the value of head to this guy. Where is it? No, we link null to this guy. Sorry, we link null to this guy. It means that it is nothing, right? But if there's something inside, so for example, if it is this guy now, right? So what we are saying is it means there's something inside. So the new node next, which is the link of this guy, will now point to where? It will point to head. Head is pointing to 20. So if this guy is pointing to 20, it means this place is filled with 20, right? So which means this guy is pointing to this guy indirectly. So head has been passed into this guy, right? And then this guy is pointing to this guy. So we then initialize the character and the data inside. That's what we did here. And then head now, that is now containing, let's say it's containing nothing now, as it is free, kind of, though it's still pointing to this guy. So what we now did is we now passed make head point to this guy, right? So head is now new node is now inside head. That's what we did. So page down, page up. Wait. So copy this guy and compare. But before that, we'll Betty. Okay, space required before the open parenthesis at 17. vi what's the file name? To add. Okay, yes, like this. Okay, so better say we are good, and let's compile. We had some compilation error. So it says that let's see, new node, not code. Where did I put code? Oh, sorry. Let's see again. Hey. Hey. Alright. Okay, so what else? This else clause does not guard. Okay. Okay, that was at 21. Let's see. Alright. 21. I'm supposed to even have return type. Then it should return the head. Okay. Okay. It didn't give me anything. I'm supposed to get something now. It means I've omitted something. Not print list. I2 add. Okay, so let's go through it one by one. So we say that if head is equal to null, it should return null. If new node, then we allocate memory for new node, which is the size of list of underscore t. And then if new node is equal to null, it should return null, right? And then if the head is equal to null, the new node next equals to null. Then else the new node next equals to head, new node string equals to string top strdup string head string length string node length equals to length str, and then head equals to new node, and then return head. Return head might be here. Control G end of main void mental. What's going on? Okay, I know what to do to you. Okay, let's see. Good. Great. So I think we are good. And then let's check our code. And this thing is taking time than I expect. We had one error. Oh, have I gitted? No. What's my last error? My last command? No. Sorry. Git add, git commit, add a node to the last, to the first. List. Git push. Yep. Start. Okay, good. So number 3, we still have how many to go? So we still have 6, 5, 4, 3. Wow, still much. Let's be fast. Let's see. Write a function that adds a new node at the end. Okay, this one is at the end. So which one should we copy first? Let's copy this guy, 3main.c. So vi3main.c, paste it. Alright, so what do we do next? Page up, create the file. What's the file name? Add node end.c. Let me copy this guy. Let me go down again. 3 add node end.c. So vi3 add node end.c. Right. So that's what we're gonna do. So for this one as well, we are gonna create the length, and also, so let's first create the length, but before that I'll do my include list.h. so it's almost the same thing. We'll have to still duplicate string, create string for it, so that's why we have to do this. So we have our int len, right, and then we have our constant character string, right, and then we'll have this, and then we'll call it int I, right, and then we'll do it if our string is equal to null, then you should return 0. So I used to use my for loop. I'll say I equals to 0, right? Oh, sorry, my while loop. While str high is now equal to null, right? I plus plus, and then you should return I. Good. So we'll document this guy. Say length is, sorry, the length of string, right, and we have our str string whose length is to be found, and then we have what our return type, amount of length, and that will be that for that. So don't forget, we'll copy this prototype and put at the top. Sorry, I thought I wasn't in start mode. Alright, so the next thing we're going to create now is we're going to write a function that will create the node, right? So I'll come here. Okay, so for that one, to create our node is list struct node, right? Our structure, and then we'll say a pointer that creates a node, the function. There are better ways to do this thing. I'm going to create a video after this, a simplified version when we have just one data in it to do all these things that we do, and it's going to be very cheap for you to grab. Okay, so this one will be constant char string as well. Okay, So what we do is to say list underscore t, that's the struct, and then we'll create memory, we'll create a pointer to it, and then remember we'll allocate memory for it. And then to allocate memory, we'll just say new node equals to malloc, and size of, and then the structure, which is list underscore t, right? Because we've type def it. Alright, so that is why. So we'll say if our, so we'll just call this function, we are just making it easier. Alright, so we'll just say if our new node is equal to null, like we did before, it should return null. Alright, but if not, then we'll say new node, right? str, the string, will then be equal to what? String doc, right? str, then we will give the length as well. New node len equal to what? Len str, right? What about the link? New node link. We know it's the last one, and the last one is always I used to call it link, it is next. The last one is always a null, right? So we want to put it at the last, and the last one is always a null, so we've already declared it, right? So that's all. And then we'll say it should return head, right? But this one will say it should return pointer to the new node for now, for this guy. So we'll then go to this guy, but before that we'll document. And this one is what? Create node, right? A function that declares or creates nodes, right? And then we have a string, to be imputed in the new created node. And then what is going to return the pointer to the node, right? Or to the allocated memory. Pointer to the malloc memory, because it's malloc that allocating memory. Alright, so and this, so this is the function itself. But before that, let me document it first. So add node and a function that add nodes to the end of the, this thing is too long, to the end of the link, right? To the end of a list. And then we have our head, which is the pointer to the first why am I doing mistake? first pointer to the first node, and then the string is the new node, right? To be added at the end, and then it should return. What is it returning? I think it should return a pointer to the head, right? Good. So first we'll say our list underscore t, that's struct t, and then we'll create a temporary, right? We'll create a temporary structure, right? Though we've not allocated memory for the temporary structure. And then we'll do our list underscore t again, and then for the new one, new node. Okay. The functions we created below are just to make our work easier. We can include them here normally. Alright. So we'll just say our tmp, our temporary, we'll give it to we'll pass head to it. So head is still our, so what we're doing here is that this is our head, right? Is here. So we created another one here, temporary, and we make it point to this guy, so that we can use it to iterate to this guy until it gets to this ending part, and then once it gets to this ending part, we can use it to connect it to this guy. Okay, so that's what we want to do. So we'll then say if our head is equal to null, that is, there's no need for us to be doing all the stress because there's nothing inside, then our new node, right, should be equal to create underscore node, and then we'll pass in our str. So it's going to create a node for this str, right? So if that one too is null, right? If our new node, new underscore node equals to null, it should what? Return null. It should return null, right? So if our head is equal to null, right, then so we're going to be initializing the list with the first node now. So we'll say alright, so if our head is equal to null, you should create it, right? So if our pointer of head is equal to null, right? Now, so what we do is say we'll give the value of head to new node, right? And then we'll return head. Okay, I think I'll spell my head. So yeah, we've created the new node, right? So if it is null, we give it null. I think you understand up to this point. So if head is equal to null, right, then head is equal to new node. That is, if our head already is pointing to null, then our new node, we want it to be null as well. So our head should be equal, we pass in the value of our new node to head. So that's basically it. So we are passing this value to head, and then we'll return head. So head will now be our first, and then since our new node is already null from here, from when we created it, so it will be the last. Okay, so if not, then while our temporary that has our head before, right, next, okay, since our temporary has our head before, so this is the next for the temporary. While our temporary next is not equal to null, it should keep going. So how are we going to make it keep going? We just say while our temporary next is not equal to null, right? Then we'll say we'll update the value of temp by what? Increasing it by temp next, right? Temp next, and then that is going to go to the next one, go to the next one, right? And then it's going to keep running. So and then our tmp, our temp next, then will be equal to our new. When it gets to the end, then we are going to assign new node to temp next. That is when it gets to, let's say it points to this point now, then our new node that is, let's say this is the null, it's pointing here, so our new node will be pointing to this guy, and since it's pointing to this guy, it's pointing to this guy, so it becomes our null. Okay, so that's what they did here. Alright, so and then we'll say it should return our edge, right? Pointer to head. I don't know if it's going to tell me to put parent guard here, but let's just try it. So compile, some is D, copy. Okay, add node. Oh, I've not added the pointer to that one. No, I've not added the prototype at the top. vi3 add node. So this one, where is it? So this guy, I'll put it at the top as well. Let's try. So one more. So increase the creation of add node end, add node end, add node end, add node end. 16 in main.c. Do you mean add node? Okay. I think I'm the one that made mistake. No, add node end. I didn't make mistake. Is add node end now? Yes. Add node end, add node end. So where did you see add node? In my main.c. Let's see again. main.c 16, line 16. Let's see line 16. Main.c 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. Head node, add node and head. Yes, now how is it implicit? Haven't I added it to the prototype? Sorry. Let me see. Maybe I've not added this to by lists. H. Add node end is here. So what's wrong with you? Wait, let me look at. Oh, it's not there. Okay, maybe I'm the one that I didn't. How did I make this one hard node? Oh, this one is from the from the previous one. Maybe it's from the previous one. Let me just leave it. Alright. So D, segmentation fault, hold on. Alright, let's check it again. Alright, so for this we have our string length, len, good. So let's check the second one. TMP new mode, malloc size of list. If new equals to null, return null. New node str equals to this new node next null. Yes, good. So the problem will be here because this is where we used malloc, and it's malloc that causes all this rubbish. Oh, we used malloc here now. Yep. Don't know. Should I free here? Should I free? No need of freeing because we are still returning it. So let me see this function very well. So list, add new node, list tmp list new node. Oh, is this guy that I posted there in the prototype? Okay. Oh, it's not the one. It's not the script node. So tmp equals to head. If head equals to null, return null. I didn't say return null. Return null. Yes. Okay. Let's try again. Okay. If clause not guard. This is let's see. If head equals to null, return null. The new node equals to create node string. If new node equals null, return null. Yes, if head equals to this, Yes. Let's see. At least the error is not much. Something that can be fixed. So number 17, position 2, VI. 17, position 2. Square now. If edge equals let me see. What's the error? Oh, see this. See this guy. Okay, so I think it's working now. Look at that small thing that's causing issue. Git add, git commit. I'm sorry I couldn't quite explain the way I want, because the way I understand it is much more than the way I am explaining right now, and it's because of the whiteboard that I'm supposed to use to explain. So I'm gonna get one. If you can recommend one from me, please drop it on the comment section. I would really appreciate, and thank you. So this one is to add node to the end of the list. Is it list that is called? I think so. Git push. So to the code. Okay, we have one issue. Alright, Betty. That might be Betty. So let's Betty 3 and yes, initial short description, create node, and then vi3 and initial short description, learn. We have learn here. Create node is here. So which short description are you looking for? Are you okay? What's the message again? Missing initial short description. 3 add node end. Okay. Let me see again. Okay, 3 add node end. That's the main one. Add node end. It has now. Okay. No, there is a space here, right? Because this thing is even making me confused. Oh, wait, no way, no way. It's like this, bro. And well, let's see. Okay. We are commit. Was that my last commit message? Okay, push. So let's check again. Good. So go to the next one, which says free list. Write a function that frees a list. That's the structure list, right? So let's copy this guy. For main.c. We're almost done. After this one, we have two more. Vi for main.c. Paste it. So vi, which other one? Vi, this guy. We'll copy this guy. We go to that. So we include our main.h. Why do I like saying main.h? List.h, right? Then we document it as free underscore list, right? This one is frees a list of nodes, okay? And then we have at head, which is the pointer to the first node. Still returning anything now. And yes, so this one will be quite easy. So first thing we want to do is we'll create a temporary, right? A temporary structure. List underscore t temporary. Alright. So we'll say if our head is equal to null as usual, first thing to say, then it should return. It means that there's nothing to free. Okay, so we'll be freeing those nodes one by one now. So we'll say while our head, so it won't get to here if our head is empty, but if you just do this thing, I think you might still get some checks. Okay, so while our head link, oh, I like saying link because I'm used to link. I used to use link, so let me use it is next. That is, so while our head next, which is this guy now, is not equal to null, so we want to be going through it one by one and be freeing them one by one. Okay, so that's what this guy wants to do. Then we say tmp, which is our temporary, right? So it is tmp that I use. So our temporary will then equal to our head next, right? So what we are doing is we are giving, once this guy points to this guy, we are giving temporary to also point to that place, right? So temporary is holding it. Okay, no, we are giving, wait, let me see, temp, yes, we are giving the value of this guy while this guy is not equal to null, while this place is not equal to null, we are passing it to temporary. Temporary is holding it. Then what happens next? Then we'll free the content. We'll free head str. We'll free head. What else? We'll free head itself, and then head will then equal to, will then give tmp to head. Okay, so I think what we're doing here is that tmp, and so why our this next is null, right? While this guy is not equal to null, right? So this guy is not null. Then we'll create TMP, right? So TMP will give it this point. TMP will be pointing to this guy now. Okay, so TMP is pointing to this guy. Okay, then we'll free this guy, right? And then we'll free head, right? And then this head will create another head, and then we'll pass it the value of TMP. So head is pointing to this guy, so it will be going like that and be releasing them from prison that they are. Okay, at the end when it gets to null, right, this guy will still be pointing, head will now be pointing to this null, right? So we'll have to free it as well. So we'll come here, and then at the end of the loop we'll free twice. And what are we freeing? We'll free head and str. Okay, and that will be all. So are we compiling anything? Do we still need to compile this? Anyway, let's see. Oh, still have some errors. Why now? Oh, we did not put our prototype in the, let me see. Oh, I've copied this guy already. So come here, copy this guy. So clear, we'll vi our 4. Is it 4 that we're doing? No, our list. And then insert I. Let's compile again. So it has reduced. So this temp we have issue last. Everybody should be first. So 1, 2, 3 E. I think that's all. Okay, we compiled, and then we have Bob. So with this, I think we are good. Let's git add and this commit free nodes, right? And then we keep pushing. There are easier ways to solve all these things. I'll show you later. So we have 2 more to go. So I'm going to be having a revision probably from Sunday upward. Okay, so if you are interested, you can drop a comment as well. I'll make a post on YouTube about it. Alright, so this one is just write a function that will print this thing before it will execute main. You know that if you write a function at the top, our main will be the first to get executed, but let's make it execute this that will print this thing before this main. This thing that is inside main will be printed. As you can see, this is what's inside main, but this guy is being printed first. Okay, so that's what we want to do. And then this one we just say 100 first C, right? So this one is simple. So vi 100 this. So we'll just say let's use include We can include, we can use stdio, or we can even use our lists, because our list contains stdio. Sorry, list dot h, right? So your lists. Okay, so let's try this. So we'll first say, we'll just say void, right? And or let me just come down first, or so let me say come first. I use two capital letters, remind me. So I said come first, that's the name of the function, and then it's going to be, so it's going to be a function that runs before the main function. That will be all, and it's going to be void. So the name will become first, right? And then it's going to take in a void parameter. And then I'm just going to use my printf to print to the screen. I can use one printf, I can use two printf if I want. And what am I printing? New line. Right. Good. And then the second one, sorry. New line. Right? That's all. It's not gonna have. But what we're gonna do to make it come first, right, is that we're going to say the prototype void, that this prototype come first, by d. Let me change the name here. Or by crypto, or let me by crypto tech coder, ctc. Okay, that's our first guy, right? And then we put our void. Right? Okay, good. So what we're going to do now is just one single line. Okay, so what we'll do is we say attribute double underscore attribute double underscore a space two bracket in the middle, and then we'll just say constructor. So this constructor function attribute, not attributor. Yes, this would help us make it come first. Simple as that. Okay, let's try and create a main.c and test. Vi under main.c, and then page down. So this one is called first, so I have to be careful not to push this guy. It doesn't matter, but I don't like pushing the. Okay, we have some errors. Alright, So vi, where do I have my error? Oh, sorry, oh, vi 100. I not put my, I'm so sorry, mosquito. I'm so sorry. 100, what's it called? 100, no, remove 100. Remove 100 now. vi 100 first. Alright. Sorry. Sorry. So I was wondering that why is my printf just blank white? And good. Let's recompile. So there's one first. As you can see, a tortoise comes last. So attribute constructor. Just remember, attribute constructor dash double underscore attribute double underscore space 2 brackets constructor 2 close brackets. Clear. So I'll git add only that 100 first, and git commit, make my function come first, and git push and clear ls. Right? So let's check. So after that, we go to the last one. We have some errors. Okay, it is Betty. So Betty 100 first. Okay. vi 100 first. Yes, sorry, it's because of my paparazzi by CTC. Alright, so let's check again. I didn't even check if the Betty is working. Okay, good, that's checked. So the last one is we have to write in assembly code. So for this one, I won't be able to explain too much because I'm not an expert in assembly code. So assembly code is simply, in compilation process of C, right? We have the pre-processing, right? We have the compilation, right? We have the assembly. So during assembly is when the code you've written, right? All these C blah 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 are converted, right? By the time they are converted to assembly code are just like arranged kind of English in a way. So they are like machine language but readable to human, right? Before they now get converted to I think before they are linked, converted to objects, and then to 0 and 1. Okay, so if you watch compilation process of C, you would get to see how um, object file is it assembly code, sorry, right? So that's basically it. So what I'm going to do now is I'm going to just go through the answer straight. I will just explain little things. There are so many ways to write it because I found that I found so many answers online. I watched so many videos about it, but I didn't want to bore myself, so I didn't dive too much into it. Probably if I have enough time, then it's something I'll just grab very well. But it's very simple. I think I wrote something down. Let me check if I still have it here. There's a system call table that you have to check. So we have the EAX, EBX, ECX, EDX. All these are general purpose register, and then we have the non-general purpose register like ESP, BP, EIP. So all these things are when you check online, system call table, right? See, write a 64-bit program. So let's see, system. What's wrong with you? Call table for 64. I don't know if there's for 64-bit or is this 64 bits? Let me see. That print this, you're not allowed to do it. Okay, let's try that. Let's check images. Okay, this is a kind of table they use in assembly code to write. So we have different register. So this table is something we'll be using. So we have all this SP3. Where is all the E? Doesn't this one has E? And this is it. This one is printing hello world, as you can see, right? DB hello world, right? So MOV, EAX, like I was saying, they are registers, they are system calls, right? EBX, ECX, EDX, right? All these things are called general purpose register. So registers are just where you can transfer content into, right? Where computer used to transfer content into them, right? So you can just watch videos on it. So I'll just go through the simplified version that I later constructed and found to be effective. So I haven't tested it before, but let me see. That's number this. Hold on a second. So that's okay. So I think it is 101 button. Yes. So they said it will be compiled using this guy. I'm going to print hello button. So we'll do this. So to write it, you just say global. Global. I don't know if it's just one. It should be one. Global main. Right, and then tab, and then you say extern printf. So this one is saying that you are bringing an external function called printf, right? And then this place you've gotten to the main, right? Okay, so this place you are moving MOV. I'm not sure if MOV is something, but you are moving something to a register EDI, right? And you are bringing format to it, right? You are moving format to the register EDI. Okay, XOR means you are exiting, like deleting. you are deleting from the register EAX. So all these things are terms, and then there are things that you just need to get to. So you are deleting EAX from the register EAX. Okay, and then you did a system call called of printf, right? So there are different ways to solve this task actually. So you can just Google and try which one, YouTube especially, and try which one will work for you. Okay, so EAX. So this move EAX, this one is saying that you are moving 0 into this register EAX, and there's a, I think when you want to write, that's when you do this. So when you want to write, I don't know if I will see something like write. There's one register I saw, and it contains all those things. When you want to write, I think this is write, but this one is for 32 bits. Look for 64 bits. So when you look, I can't find that. See all these things. I'm looking for the one that. Oh, wait, I saw one now. Oh, it's not this one. Yes, something like this. Something like this. So they use all these registers. Look at the registers here. ESI, all these things. They check right, okay. Right, you pass in the value. What are we doing? EAX, right? Let me see. EAX, where's EAX? So to write, you pass in, I think 0 into EAX or something like that. So this, you have to know how to just read the stuff and then understand it. That's it. So something like that. This is how it's done. It's not something I'm really good at. So we'll say you should return the format, right? Did that DP that we saw the other time, and then we'll press in our word. So hello Holberton, hello Holberton, and then we'll end it with this again, and then we'll pass in 0 to it to end it. This is the null. Okay, it's called the null character or something. So that will be all. Let's save, let's compile. So to run, let's run hello Holberton, right? So but it printed it with a new line. I don't know how we're gonna add that one. So let's git add first and see if that one works. 101 hello button. Wait. Let me first do ls first. Let me know what I'm adding. Oh, it has created 2 files for us. So I'll git add. Let me git status to see if I've not added that one. Okay, I've not added it. Good. So git add 101 dot asm, git add git commit, use assembly code to print hello Holberton to the screen. The push. Okay, So let's check. It's almost checkout time, that's why we're having delay. So I'll just wait a bit. If it doesn't check, if it checks, I'll upload it. But if I don't upload it, then it didn't check, then I'm gonna edit it and I'll add it to this video. So let's hope it has checked. So in case you see that it stopped here, it means it has checked. So thank you for watching, and yeah, so like I said, on Sunday we should have a class. I don't know, I'm thinking of we should have a revision so that it's going to help, because I want to revise actually. So I'm just using the opportunity to carry people along, and then yeah, so see ya.